Hi, I'm Yasuhiro Ohara from NTT Communications Corporation. In this session, I'd like to introduce a Linux-based software router to the Arm community. The NTT Communications and SOUM Corporation jointly produced the software router. Kamuee is the name of the software routing engine from NTT Com, and eMAG is the commercial product based on the Kamuee from the SOUM Corporation. Kamuee runs on Ampere eMAG 8180 server with the performance depicted in the figure. As you can see, the performance is sufficient for the multiple 10 gigabit Ethernet NICs. The prospects are good because on the Intel Skylake 2 socket server, we have achieved more than 200 gigabps with the shortest 64-byte Ethernet frames in a system total performance. That is more than 300 million packets per second. That is 300 megapps. With the newer ARM's high-performance server, the router's performance will increase as a matter of course. Another point you can see is that as you put more CPU cores per NIC port, the performance also increases. This is another good aspect of SD and NFV. You can control the performance by the amount of hardware resources you invest. From the performance measurement, we see we can get almost wire rate performance of 30 gigabps already. In the shortest Ethernet frame size of 64 bytes, the wire rate can be achieved at around 8 cores per port setting. Let us get back a little bit on the benefit of the software router in the first place. Software router is said to be good in SD and NFV in many reasons. One of the most practical reasons will be that you can choose your hardware by yourselves. You can select the most reliable or most reasonable hardware for you. This will avoid the vendor lock-in program and will make the price reasonable in the long term. We have a little bit unique points in our product. We developed our unique routing lookup algorithm called PopTry. The full academic paper of PopTry is published in SIGCOMM 2015. PopTry supports roughly up to 2 million routes without major performance degradation. Kamuee can run with FRL, the free-range routing open-source software. Collectively, these mean that Kamuee supports BGP full routes routing in the range of multiple 100 gigabit Ethernet NICs per chassis. To the best of our knowledge, this is the unique value in Kamuee. We will be providing our Kamuee source code at your request. We are seeking the development partners. You can join our development as partners or purchase the source code from us. In any case, we will be developing the advanced technologies further, additionally on this platform. This slide pictures the internal structure of Kamuee. The Kamuee's 4 other threads, placed on top of each core depicted in the middle of the figure, middle of the slide, is the monolithic function that does all the packet handling process. It takes the run-to-completion model, where a packet is processed entirely by a single core, is one reason for the superior performance of Kamuee. It is as simple as that. you can insert a custom function in the forwarder to implement your special packet treatments. Above the forwarder are the lib and fib, the instances of the routing tables. The fib implements the pop-try algorithm, which provides the scalability against the large number of routes. Kamuee interacts with the Linux routing table through the netlink socket. In this way, OSS technologies like FRL can be attached, enabling the exchange of Internet full routes with the BGP protocol. As one example of Kamuee use cases, we contributed in a multicast streaming event, the Sapporo Yukimatsuri event. In the event, the Kamuee box exchanged the PIM-SM routing protocol and forwarded multicast traffic from one upstream to two downstream sites. The multicast stream carried an uncompressed 8K UHD TV live video. The traffic on one multicast stream was about 51 gigabps, that is 800 kbps in the unit of 8 KB jump frames. We can support such high bandwidth traffic in a software router nowadays. Upcoming ARM servers are promising. Higher number of cores will be good for balancing the resources between the network functions and the tenants. We will be able to take advantage of next generation bus technologies such as PCIe Gen 4 and CCIX with a low CPU power consumption. It seems we will gain better selection options from ARM family vendors for telecommunication infrastructure and NFV. Using upcoming ARM high-end servers, we will be able to achieve around 300 to 400 gigabps per chassis. And when we integrate 3 to 4 chassis as one router, it would reach as much as terabps class router by software. eNow, the commercial product based on Kamuee, will debut soon in early next year. The price will be a one-time fee for each instance. Please check out this URL if you are interested. Conclusion of this presentation is as follows. NTT Com and SOUM jointly introduced a software router family called Kamuee and eNow. Using Kamuee and eNow on ARM high-end servers, you can build a Linux-based, full routing-capable software router. Thank you for listening.